Approximately 1/4 of Canadian seniors reported having some kind of physical, cognitive, or sensory impairment that affected their abilities to perform the common activities of daily living required to maintain their functional autonomy and independence. The focus of Work Package 3 is the development and evaluation of technologies that will support older adults and their caregivers through a variety of physical and cognitive activities, thereby increasing mobility, participation, and independence. In this talk, we will introduce you to the objectives and research activities in Work Package 3 via 3 core projects. The first, VigilRobot, which is mobile robots for telepresence and activities of daily living assistant. The second, Copilot, a collaborative power mobility for an aging population. And the third, Diade, do-it-yourself adaptable intelligent domestic environments and their sub-projects. Over the next 20 minutes, we aim to give you some insight into our work package, our core projects, our team, and some of the highlights to date in pursuit of achieving our objectives.
Hi, I'm Dr. François Michaud from the Department of Electrical Engineering and Computer Engineering at the University of Sherbrooke.
Hello, I'm Professor Goldie Najat, Canada Research Chair in Robots for Society and the Director of the Institute for Robotics and Mechatronics at the University of Toronto. Our project is entitled VigilRobot, Mobile Robots for Telepresence and Activities of Daily Living Assistant. The overall goal of this project is to develop mobile and interactive robots to be used as a telecommunication platform for older adults and their caregivers, to provide cognitive assistance for activities of daily living, as well as scheduling for both the user and the robot. In order to achieve this goal, we focus on the development and integration of such capabilities of sensing users and the environment that the robot is in, being able to move to different locations, as well as interacting naturally with users. We will also conduct user-needed assessments and technological evaluations with older adults within their everyday environments. One technology we are developing at the University of Toronto is the socially assistive robot Casper that can assist a person to complete activities of daily living using speech, facial expressions, and gestures.
Work Package 3.2, co-led by Dr. Joël Pinault from the Department of Computer Science at McGill and Dr. Bill Miller from the Department of Occupational Science and Occupational Therapy at the University of British Columbia, is entitled Copilot. Copilot is a short form for collaborative power mobility for an aging population. One of the challenges with standard powered mobility devices such as powered wheelchairs and scooters is that they can be difficult to learn to use, especially for older adults who have a variety of physical, perceptual, and cognitive limitations. The overall goal of Copilot is to improve powered mobility device options for older adults with mobility disability by enhancing device design and training options. Copilot powered mobility design objectives focus on the development of collaborative control systems or modules that will allow users to independently mobilize in their environments. Collaborative control will enable the powered mobility device and user to share control to ensure safe mobility when increased personal and environmental challenges are encountered. Development of Copilot training options currently consist of 2 approaches. The first approach is virtual reality. Here, the powered mobility device user learns different skills in a variety of simulated situations. The second approach for training, teleoperation, allows shared control of the mobility device by both the trainer and the mobility device user to learn skills in a graduated series of supervised trial and error challenges. To achieve our design and training objectives, we rely on an iterative, user-centered design that involves end users throughout the development and validation processes so that the technology meets the needs and is valued by the end users.
Hello, I'm Dr. Hélène Pigot from the Department of Computer Science at Sherbrooke University, Quebec. I'm colleagued with Dr. J.C. O from University of Waterloo for project WP3 called Diade. The Sherbrooke team is composed of Professor Sylvain Giroux, expert in smart home and autonomic computing, and Professor Dominique Laurin from the Department of Psychology, specialized in sleep and cognitive disorders.
My name is Jesse Hoey from the University of Waterloo. The overall aim of the DIY Aid project is to fill the gap between the knowledge pileup in scientific research on smart homes and the production of technologies that families could practically install in the homes of older adults in need of assistance. We believe that informal caregivers and even persons in need of assistance are those with the knowledge to enable customization of smart home technologies. We believe that we can leverage this knowledge to build more effective, adaptable, intelligent domestic environments, aka smart homes. The DIY Aid project aims to connect older adults attempting to age in place, caregivers, technology developers, and researchers across an inclusive platform that allows for symmetric flow of information between the groups involved.
In DIAD, older adults are prompted by intelligent assistive systems to complete ADL and can provide feedback on what works and what doesn't. Caregivers can view technology performance and can customize the assistive technologies to better suit changing needs. Technology developers and designers can be informed of requirements and can propose novel solutions. And researchers can engage directly with end users in participatory or co-design projects.
We have developed a middleware platform that connects various stakeholders symmetrically and inclusively. The platform connects sensors and actuators through a common backbone and has interfaces for technology developers, caregivers, researchers, and medical experts. We have also worked on the first set of prototype assistive technologies to connect to the DIY Aid platform. Specifically, to promote autonomy at home, we have developed Coach, a hand washing system that assists older adults to get their hands washed. The coach uses a virtual human to deliver prompts that are emotionally aligned with the identities of the older adult. A facial point tracking system detects facial expressions and tracks the user's head pose and eye gaze. The detected facial expressions are used as measurements of the person's emotional state and identity.
We have also developed a nighttime wandering assistance thanks to sensors and actuators such as light and music to create a reassuring atmosphere suitable for going back to bed. Based on a literature review on what activities of daily living are impacted and when throughout the evolution of the disease, this project will be extended for other ADLs such as eating and dressing to foster autonomy among elders. To ensure the reliability of the diet kit, we developed an autonomic system providing suitable redundancy in smart home equipment. This results in a sensor network that is responsive in case of sensor failure. Finally, we are concerned by the way DIAD will interact with caregivers in order to determine the appropriate kit according to the elder's habits and capacities and according to his home environment. That is why we designed a virtual environment that allows caregivers to customize the system's features.
To help understand what are the needs of persons with dementia on a psychological level, we have interviewed over 30 caregiver and older adult dyads and done qualitative analysis to develop a guide to help understand emotional identity in Alzheimer's disease. This guide is operationalized according to the principles of affect control theory, a comprehensive social psychological theory of social interaction. The guide is meant to be used as a validation or instructional tool for caregivers and family members. It will also be used to design emotionally aligned modules within DIY Aid. The guide highlights the fact that, while identity loss is a hallmark of Alzheimer's and dementia, a core sense of self on an emotional level called a persona remains stable and intact, and that paying attention to this persona is critical for effective caregiving and for the development and adoption of technology for assistance.